Hello, today I want to cover lecture for matrix multiplication. So, first we will see whether the multiplication is defined or not. Defined here means whether the product of a matrix is possible or not. So, for the product of the matrix to be defined, the column of matrix A column of matrix A should be equal to the row of matrix B. Like this we have taken, let A is a matrix of order m cross n, m by n, and B is matrix of order n by p. So column of A matrix should be equal to row of B matrix. Column of A matrix should be equal to row of B matrix, then only the matrix is defined, means then only the matrix multiplication is possible. Next is, after multiplying, what will be the order of the product of matrix? So if we have taken product of A and B matrix and suppose that matrix is say C, so then order of that matrix will be the remaining, what remained of A is row and remain of B is column of B matrix. So the order will be M by P. So product of the matrix AB, its order will be M by P. Next, in matrix, if we want to calculate certain element, any element, suppose we have calculated a product of any matrix, we have two matrix A and B, and we want to calculate only a single element, any element. Suppose any element is like this, 3 AB 3 2. Okay, so what we have to do, we have to take the ith row element of A matrix and kth column of B matrix, and we have to multiply each element correspondingly, and then we have to sum that, all that products we have to sum, then that will be the product, that will be that respective AB 3 2 or AIJK element. In coming slide we will see, we will verify all these things with example whether the product is defined, and we will see the order also, and we will find element corresponding or a single element how we have to find. So in this slide we will see whether the product is defined or not. So now we will see whether the product of the matrix are defined or not. So first we will write here the order of these matrix. So what is the order of this matrix? This is 1 row and 3 columns, so it is 1 by 3 matrix, and this is 3 by 2 matrix, this is 2 by 2 matrix, this is 3 by 3 matrix, and this is also 3 by 3 matrix. Now let's see whether the AB is defined. What is question is saying? Verify that the product are defined or not. If defined, what is the order of that matrix? Okay, so AB, first we have to take AB here. AB, what is the order of A? Order of A is 1 by 3 and order of B is 3 by 2. So here column is equals to row, so this matrix is defined. And what is the order? order is remaining of A and B. So order will be 1 by 2. Similarly, we will take next example B, A. So here we will write first the order. What is their order? So order of B is 3 by 2 and order of A is 1 by 3. Here column is not equal to row. So this matrix is not defined. If not defined, then no need to calculate order. Okay. Next we will see VBC. Okay. So BC, what is the order of B? Order of B is 3 by 2 and order of C is 2 by 2. Here column is equal to row. So column is equal to row, so it is defined. And if it is defined, then what is the order? Order will be 3 by 2. Similarly, next we will take next example A, C. So here we will write A order. What is order of A? 1 by 3 and order of C is 2 by 2. Here column is not equal to row, so it is not defined. Okay. Next we will take next example is CB. CB. What is its order? See, order of C is 2 by 2 and order of B is 3 by 2. Its column and row. Column is not equal to row, so it is not defined. Next example is CD. Okay, C, what we will take? C order is 2 by 2 and D order is 3 by 2. So these are not equal, so it is also not defined. Next we will take next example B. Order of B is 3 by 2. Order of D is 3 by 3. Here also column is not equal to row, so it is also not defined. Next we will take D, B. What is order of D? D is 3 by 3 and B is 3 by 2. So here column is equals to row, so it is defined and its order is we'll write here order is remaining is 3 by 2, so order will be 3 by 2. Next last example is D, E. Here D is 3 by 3 and E is also 3 by 3. So here column is equals to row, so it is defined and its order defined and its order will be 3 by 3. Okay. Next we'll take next example. Here what we have to find? We have to find out the respective element. Okay, as I have told that we have what here it is asking? It is asking to find out the AB, product of AB, and which element? In product element, which element we have to find? We have to find AB 1, 2 element. Okay, so here we will see what is the order. Order is here 1 by 3 and its order is 3 by 2. Here column is equals to row, so its multiplication is possible and it is defined. So we need to find out. So first I will explain here how we can solve it. So you have to take the AB, means A's first row, one row. Okay, so you can write it like this: 5 1 4, and which column? Second column. So you can write it here, second column, means this is the A's first row and this is B second column, that is 1 3 4. You have to multiply each respective element and then you have to add each of these product. You have to add all these products. Okay, so for solving this, means what you are doing, you are taking 5 1 4 row of first A and column of what you have to, what it is, it has asked, means it has given that you have to take second column of B matrix. So second column will be 1 3 4 and you have to multiply respective element, 5 into 1, 1 into 3 and 4 into 4. So what will be the, here we can do like this: A B 1 2 element will be 5 into 1 plus 1 into 3 plus 4 into 4. So answer will be 4 4 is 16, 16 plus 3 19, 19. Second 19 plus 5, that is 24. Okay, next what you have to find? You have to find B C, which element? 2 elements. So what you need to do, you have to take matrix B second row and matrix C second column. Okay, so here I can tell you separately like this. You have to take B first second row. What is second row? Second row is 0 3 and you have to multiply, this is row, okay, of B row and column of C column, second column. What is C second column? 1 2. You have to multiply each. So what it will become? It will become 0 into 1 plus 3 into 2. So answer will be 6. Next, what you need to find? You have to find D E 3 tooth element. So you have to take D's, what you need to do? D's third row, this is third row and second column. So you will need to multiply. So it will be 1 into 1 plus 5 into 0 plus 3 into 6. So it is equal to 3 6 is 18, this is 0 and this plus 1 will be 19. So like this you can, without solving whole matrix, you can, if it has asked only only single element, so without solving whole matrix you can only find out the respective element. Next is matrix multiplication. So let's solve it. So what is the order of this matrix? This is 3 by 2 matrix and this is 2 by 2 matrix. Here column is equals to row, so this matrix is defined means matrix multiplication is possible. And what will be the order? Okay, so order will be 3 by 2. 3 by 2 matrix. Okay, so first we can see what will be the element of 3 2 matrix. Means it will be having 3 rows and 2 columns. So we can write here the matrix. First we can write what will be the elements of this matrix. So what will be the element? A, B, first row, first column, A, B, first row, second column. Similarly, A, B, second row, first column, A, B, second row, second column. Next is A, B, third row, first column, and A, B, third row, second column. These will be the element. Now let's solve it. So no need to write this, only for understanding I am doing this. You can directly solve AB matrix. So AB matrix will be, so you have to multiply row with each column. So first element of this AB11 will be 2 into 0 plus 1 into 6. This is AB11 element. Next will be 2 into 1 plus 2 into 2. Similarly, next AB21 element will be 4 into 0 plus 3 into 6. Next 4 into 1 plus 3 into 2. AB31 element is 1 into 0 plus 0 into 6. Next element AB32 element will be 1 into 1 plus 2 into 0. Now after solving we will get here, what we will get? We will get 2 into 0, 0. This is, here we will get 6. This we will get 4. Okay. This 0, this is, we will get here 18. This here 6 plus 4, 10. This will here get 0 and this is 1. So this is the answer of matrix, product of matrix AB whose order is 3 by 2. Next we will see product of matrix multiplication, non-commutativity of multiplication of matrices. Non-commutativity of multiplication of matrices. First is this, we have to see that if AB is defined, BA may be defined or may not be defined. This says that if AB is, multiplication of AB is possible, BA may be possible or may not be possible. Here like this, here this is what is the order, here is 3 by 2 and this is 2 by 2. Here if we want to take product of AB, then it is possible because column is equals to row. So AB is possible, that AB is defined and its order will be 3 by 2 after multiplication. But if we want to do BA, so what will be BA? BA is order of B is 2 by 2 and A is 3 by 2. Here column is not equal to row, so it is not defined. So in non-commutativity, it is not mandatory that if AB is defined, BA should be defined. BA may or may not be defined. Next point is, even if AB and BA are defined, AB and BA are not always same. So matrix multiplication is not commutative. Like this, if we take this example, it's this order of A is 3 by 2 and the order of B is 2 by 3. Here AB is defined. AB is defined and order of AB after multiplication will be, order will be 3 by 3. If we take BA, then it will be, what will be B? B is 2 by 3 and A is 3 by 2. So it is defined and its order will be 2 by 2. So both are defined, both multiplication is possible, but they are not same, because we are seeing here that their order is of different. It is 3 by 3 matrix and it is 2 by 2 matrix. So they are not same. For equality of matrix, we know that for equality matrix, the condition is that their order should be same. Order should be same, and then next condition is this, that after order is same, then each corresponding element should be equal. Each corresponding element should be equal. Then only the matrix is said to be equality matrix. So here we can see that second point, that even if AB and BA both are defined, then also it is not necessary that AB and BA are same, and so matrix multiplication is not commutative. Last is this, as an exception, only in some cases, exceptional cases is diagonal matrix only, in which AB is equal to BA, because in this both their order will be same and their corresponding elements also will be same, and we will get the matrix only by multiplying these diagonal elements. We will get the respective matrix. So we can see here that 2, 4, 8, 5, 1, 3, there its order is 3 by 3. If we take here AB, it is also 3 by 3 matrix, and BA also 3 by 3 matrix and 3 by 3 matrix, and both are defined and they are equal also. AB is equals to BA, because if we multiply, after multiplying, its rule is this, that we can get matrix multiplication all by multiplying corresponding diagonal elements. So 5 into 2, 4 into 1, 8 into 3, or this, if you do BA also or AB also, we will get this same matrix. So this is the exceptional case. Next is this, matrix multiplication of a null matrix with, if we multiply any matrix A with a null matrix, then it will be also a null matrix of same order. In this we have to see only this, that these both are defined, that the column of A should be equal to row of null matrix, then only it will be possible, and then it will be equal to null matrix. Or if we do O null into A matrix, then also it is a null matrix. If we take this example, if we multiply A by A, null matrix, here we see first it is defined or not. This is 3, this is 3 by 2 matrix, this is 2 by 3 matrix. Here row, column is equals to row, so it is defined. If we take OA will be what? This is 2 by 3 matrix, and this is 3 by 2 matrix. Here also both are column is equals to row, so this is defined in this example. So these both are defined, OA or AO both are defined, so they are null matrix. So null matrix as a product of two non-zero matrix. Here it is saying that if we have two non-zero matrix, A and B are non-zero, that they are not a null matrix, but their some elements are 0. So if in some cases it is also possible that if we multiply two non-zero matrix, then their product will be a null matrix. Next, now see the matrix multiplication properties. So what is first property? First property is associative law. So what associative law says? That if we take product of AB matrix and then multiply it with C, then it is equal to, if we first take product of BC and then multiply it with A. So they both are equal, and this is a associative law. What is second property? Second is distributive law. In distributive first property, what it is say? It says that if A is multiplied by the sum of B and C, that will be equal to the product of AB and then taking its sum with AC. So these both are equal. Second property says that first if we add A and B and then multiply it with C, that will be equal to, if we separately take product of AC and BC and then if we sum them together, that will be equal to A plus B multiplied by C. So third property is existence of multiplication identity. Existence of multiplication identity is only possible for square matrix. Like what is a square matrix? That should be of same, means row is equal to column is equals to row, that is a square matrix like this: 1 by 1, 2 by 2, 3 by 3, 4 by 4. So in square matrix, if identity matrix is multiplied with matrix A, that will be equal to, if A is multiplied with identity matrix, that is only A matrix. So now let's solve this example. We will see how to find out the value of x. So here first we are taking, right, first we see what is the order of these two matrices. So what is the order of this matrix? Order of this matrix is, we'll write here separately x1, one second, erase this, so we will write here separately x1. So what is the order of this matrix? This is 1 row and 2 column. And what is the order of this matrix? 1 0 minus 2 0, and its order is 2 by 2 matrix, that is equal to null matrix. So here column is equals to row, so it is defined and we can perform its multiplication. So what will be the order of this product of this matrix? Product of this matrix, the order will be 1 by 2. So 1 by 2 matrix we will get, and for solving what we have to do, we have to multiply row with each column. So let's start. X into 1 minus 1 into, so first we'll write here plus and this is minus 2. So this is matrix, and second what we'll get, if we multiply x into 0 plus 1 into 0. So this is 1 by 2 matrix, that is equals to of null matrix of same order. So we have to write here null matrix of same order, that is 1 by 2. So 0 0, then only we can equate, because equality matrix the order is same and each corresponding element will be same. So what we'll get here, we get here x minus 2 and 0, that is equals to 0 0. So by equating corresponding element we will get x minus 2 is equals to 0, and finally x is equals to 2. This is the value of x. Let's take another example. So here also first we will see what is the order of this matrix. This is 1 by 2 matrix, this is 2 by 2 matrix, and this is 2 by 1 matrix. So for performing multiplication, this both should be defined, and we see that column is equals to row, so it is defined. So let's first multiply this. So we will multiply row with each column. So 2x into 1 plus minus 3 into minus 3, and what will be the order we will get? We will get 1 by 2 matrix, and next element what we will get? We will get 2x into 2 plus minus 3 into 0. This we will get 1 by 2 matrix, and this is here x3, that is equals to 0, that is null matrix. Okay, next step is we have to solve this. So we will get here 2x plus 9 and 4x. Okay, and next is we will write this one, this matrix, that is equals to null matrix. So here also this is 1 by 2 matrix, this is 2 by 1 matrix. Here column is equals to row and what will be the order of product of them after multiplying? 1 by 1. So now let's multiply these two as it is defined. So 2x plus 9 into x plus 4x into 3. This is matrix is 1 by 1 matrix is equals to 0. Here also we will take 1 by 1 null matrix. Okay, so what is this? After solving we will get here 2x square plus 9x plus 12x is equals to 0. So we will take x common here, x common, we will get here 2x plus 21. Okay, we have to separate this. So next step is, this is after this step, then this step, this is equals to 0. So we can equate this. So two values of x we will get here, x is equals to 0, and then next we will get 2x plus 21 is equals to 0. So value of x will be minus 21 by 2. So this is the two values. One value is x is equals to minus 21 by 2 and one is x is equals to 0. So this is next. Okay, let's take another example. This is what we have to find. We have to find the, if matrix A is this and A square is equals to KA, then write the value of K. So we have to calculate the value of A. So for this we will first calculate the value of A square. So what is A square? A square is A multiplied with A. So first we will, let's calculate the value of A square. A square, for A square we will take A 1 minus 1 minus 1 1 multiplied by 1 minus 1 minus 1 1. Okay, so here we will calculate the value of A square. So A square will be 1 2 by 2 matrix. So we will solve row into column. So 1 into 1 plus minus 1 into minus 1. Okay, 1 into 1 minus 1 into minus 1. Next element will be 1 into minus 1 plus 1 into minus 1 plus minus 1 into 1. Okay, that should be, here we will write here, that should be equal to K A. So, and next this is minus 1 into 1 plus, this 1 into 1, 1 into minus 1, here it will be, it comes minus 1 into minus 1 plus minus, one second, minus 1 into 1 and minus 1 into 1 and 1 into minus 1, this is minus 1 into minus 1, this is 1 into 1, 1 into 1. We need here space to write, so it will turn out to be, this is 1 into 1, this will become 2, this is minus 1 into minus 1 plus minus 1, this will be minus 2, this is minus 1 minus 2, this is 1 cancel, 1 plus 1 is 2. This is, so now what we can take here common, here we can take 2 common, so it is 1 minus 1 minus 1 1. So we can see here that this is A, so it is 2A. So what we got here, A square is equals to, no, not like this, means it has come to be 2A, so it, the value of K here is equals to 2, because A square is equals to what we got, 2A, so we can say that K value will be 2, so 2A it has come. Now let's take another example of this one. Here what we need to find, we need to find out the value of K. So what we have, what is given is this, A square is equals to Ka minus 2I. Okay, so if we want 2I, first we will calculate what is value of, we will separate it, so it is easy to find out. First we will write, find out the value of A square. So A square will be 3 minus 2, 4 minus 2 into 3 minus 2, 4 minus 2. So after solving this, we will get what, 2 by 2 matrix only we will going to get, because this is square matrix. So 3 3 ja 9 minus 4 2 ja 8. Next is 3 2 ja 6. This is means multiplying 3 into 2, this column. So we will get here minus 6 and 2 2 ja 4 plus 4. This is 4 3 ja 12 minus 8. Here we will get 4 2 ja 8 means minus 8 plus 4. So after solving this, we will get value of A square. What is A square? A square will be 1 here minus 2, this is 4, this is minus 4. Okay, 1, this is A square. And if we want to take 2I, so what will be 2I? 2I will be, we are multiplying I with 2, so 2I will be 2 0 0 2. Now let's solve this equation. So for what is equation is given, A square is equals to Ka minus 2i. So here we will take A square and we will multiply, we will add 2i here and subtract 2i here. So this is nullified and that is equal to Ka minus 2i. So here we will write value of A square, we will substitute here value of A square, here 2i. So we will, what we will write here, 1 minus 2, 4 and minus 4. We will write here plus 2i value. 2i value is 2002 and minus 2i is equals to, okay, this is implies, okay, so this is equal to Ka minus 2i. We will cancel out this 2i and we will solve this. So here we will get 3 minus 2, 4 and minus 4 plus 2 will be minus 2. This is equal to Ka. So we see that this is the value of A and what will be the value of K will be 1, because it is multiplying by 1 only, we will get the same matrix. So what we see here? We see here that the value of K is 1. Let's take another example. So here we have to see, we have to calculate, we have to first form the matrix. So what is the question? Question says there are two families A and B. There are 4 men, 6 women and 2 children in a family A, and 2 men, 2 women and 4 children in a family B. The recommended daily amount of calories is 2400 for men, 1900 for women, 1800 for children, and the requirement of protein, 45 grams of protein for men, 55 grams for women and 33 grams for children. And it is saying that represent the above information using matrix multiplication. Using matrix multiplication, we have to calculate the total requirement of calories and proteins for the two families. And what awareness can you create among people about the balanced diet from this question? So first we will create a matrix for families A, P with how many men, women and children. So in family A, how many men? 4 men, 6 women and 2 children. In family B, 2 men, 2 women and 4 children. And second matrix we have formed that what is the requirement of calories and protein for men, women and children. So here we see that we have to find out, as it is saying that you have to calculate the total requirement of calories and proteins. So we have, when we will multiply family A, as in multiplication we multiply row with column, okay. So when we will multiply this family A, men, women and children with each calories with column, yeah, as it is formed, then we will get the total calories requirement. Similarly, when we will multiply with this column, we will get the protein requirement. So it is means I want to say that you have to form the matrix like this, logical only, so that if you what answer, what it is asking, if we are getting by, we have to see that by multiplying, after multiplying the required data, you are getting your answer or not. So you have to form the matrix like that way only. So here, as we have seen what it is asking, we have to calculate the total calories and protein requirements. So what we need to do, we have to multiply this with this. Suppose this is a matrix X and this is matrix Y. So we have to multiply X and Y. then only we will get the total requirement of calories and protein for each family. Okay, so let's multiply. So if we will multiply, let's see. So what is the order of this matrix? This is 2 by 3 matrix, and this is 3 by 2 matrix. Here column is equals to row, so this is defined. And what will be the order of matrix? Finally 2 by 2. So let's multiply. So 4 into 2400 plus 6 into 1900 plus 2 into 1800. This is the calories requirement of family A. And next we will calculate the protein requirement by multiplying each row with column. So 4 into 45 plus 6 into 55 plus 2 into 33. Similarly, 2 into 2400 plus 2 into 1900 plus 4 into 1800. This is protein requirement of family B. And now this is calorie requirement of family B, and now protein requirement. 2 into 45 plus 2 into 55 plus 4 into 33. So when we will solve this, we will get this is 9600 plus 11400 plus 18 to 3600. Next this is 180 plus 330 plus 66, and here it will be 4800 plus 3800 plus 7200. Here 90 plus 110 plus 132. So after solving this, this is equal to, next step is this. After solving, we will get here, how to write, space is there. So we will get the answer here, 246600 576 and 1515800 and 332, 2 by 2 matrix. So this is the calories requirement for family A, this is protein requirement for family A, this is family A, this is family B, this is protein requirement, and this is calories requirement. For family A, protein requirement, calorie requirement, this is family B, protein requirement and calorie requirement. So by seeing this question, we can say that what required amount of calorie is required for each family, or man or woman, or calories or protein, that should only be taken for a balanced diet. Otherwise it will be unbalanced and it can cause many diseases. So we have to always take a balanced diet. Thank you, and you can visit our this website for exercise. Exercise is there with each video with their answers only. Solution you have to do and match with the answers. Thank you very much.